Hello and welcome. In this video, I'll be going over how to set up a Python virtual environment for a project on Linux or macOS. By the end of this video, the topics covered will be what a virtual environment is, setting up a virtual environment with Python, and creating a simple Python program in a virtual environment that makes an HTTP request to a web page and displays the raw contents of the page. So what is a virtual environment in the Python world? Well, typically, with a Python project, there are a set of dependencies in the form of packages that a developer would need to install and use. Some of these are included with Python and others are installed with a tool such as pip. A virtual environment is mainly used to isolate dependencies that are used in a project, removes the possibility of conflicts with programs that were developed with an older version of a package, make the project transportable between different systems. A list of packages can be exported to a file to make setting it up on another system very easy. And finally, specifying a particular version of Python and/or a package to use. Now, why would you need to specify a version of Python to use, you may ask? The reason is very simple, in that some packages may only work with certain versions of Python. For example, say a new version of Python is released and is installed on a system. A package may not work on that version as it may not have been tested or updated to work with it, and as a result could cause unexpected issues. I've had that happen a few times, so always check that the package is supported. The easiest way to check is to search for the package on PyPy and look for the tags in the description of the package, which versions is the highest and which ones are the lowest. For example, if you search for the request package on PyPy, in the description, you can see that it requires Python 3.8 or above, and the highest supported version is 3.12. This is as of November 2024. Before you can use a Python virtual environment, you'll need a version of Python 3 installed, along with the pip command, and a terminal emulation application, such as the one built into your OS or a third-party one. For reference, in this video, the version of Python used was 3.12.7, and iTerm 2 was the terminal emulation application used on macOS. The first thing to do is to see what packages are currently installed at the system or global level. What this means is what Python packages are installed that can be used without the use of a virtual environment. To see what packages are installed, we run the pip list command. As you can see, the output lists a number of packages and their associated versions. Now, your output might be similar to mine, but the likelihood is it'll be different. And that list is all the installed packages that are available at the global level. Before a virtual environment can be created, a folder for storing all the files for the project needs to be created first. For this project, I'm going to create a folder in the downloads folder called example and change to that folder directory. I'm going to do this by doing cd space downloads, then mkdir example, and lastly running cd example. With the project folder all set up, a virtual environment can now be created. To create a virtual environment, there are two ways to do it. The first is with the virtual env package, and the second is to use the built-in venv module in Python. For this project, the venv module method will be used. To create a virtual environment, simply run python 3 -m venv venv. To go over what the command does, Python 3 is the Python interpreter program to use. -m indicates a module is to be run. The first venv is the name of the module. The second and final venv is the name of the folder that will be used for the virtual environment. Next, run the ls-lha command to see the newly created venv folder. By default, the virtual environment will use the version of Python that is the default on your operating system. If you want to use a different version, specify that version instead. For example, use Python 3.11 instead of Python 3 to use Python 3.11. If you use the project on another system, you will need to ensure it has the same version of Python installed, and you specify that version when you recreate the virtual environment if it isn't the default on that system. Now that the virtual environment has been created, it now needs to be activated. If it isn't activated, it will install any packages at the system or global level. To activate it, run source./venv/bin/activate in the folder for the project. Now, depending upon how or if you have customized your terminal, you should see venv show up on your command prompt. In my case, it's the folder name, but don't worry about that. On a default bash or ZSH terminal, it should look similar to what you're seeing on the screen now. With the virtual environment now active, you can check it by running the pip list command again. You'll notice that the list is different from before. If you need to exit the virtual environment, simply run deactivate at the command line. You will see that venv is no longer shown in your command prompt. You can reactivate it again by simply running the source command that was previously run. Also, if you close the terminal, this will also deactivate the virtual environment. For now, please ensure the virtual environment is active. To install a package into a Python virtual environment, it's no different than installing it with the global environment using pip. For this project, install the requests and zip packages using pip by running pip install requests zip. Once the installation is finished, run pip list again, and you should see the two packages installed, along with some additional packages that were also installed as dependencies for both the requests and zip packages. It should look similar to what you're seeing on the screen now. All the packages that are shown on the screen will be isolated from any other Python virtual environments and the system/global environment. This means that if you didn't use the virtual environment and try to use the request package, it will not work unless you install it into that environment. Removing a package is very much the same as installing a package, but you need to use uninstall instead. To do that, simply run pip uninstall zip. Once the uninstall is finished, run pip list again, and you should see that the zip package is no longer listed. For example, on my screen, there's no zip installed at this point. Now that the request package is installed, let's start using it. But what does it actually do? Well, the request package, if you haven't used it before, is used to make HTTP and HTTP requests to a website and bring back the contents of the page as raw HTML. It can do a number of other things, but for this particular project, it will just be used for making a simple HTTPS request and reading the contents of the response. First, we need to run the Nano text editor and create a file called main.py, and we do that by running nano main.py. Once Nano is opened, I'm going to copy and paste the code in for this particular project. Just to give it a quick once over, we've got two imports at the top that we need to do. One is the request and one is pretty print. Next, we've got the URL to use, which is mirrorservice.org. Then we've got a get_request variable, which actually does the request. And then what we do after that is we run pretty print just to output the actual HTML of the request, more specifically the response that it got back. And then lastly, it'll just show what the HTTP response code is, which, if it's successful, will be a 200 OK. Next, save the file by pressing Ctrl and X, and then press Y when asked about saving the buffer. Press Enter when asked for the file name. It should still be main.py. This will now take you out of Nano and back to the command prompt. To see what the application does, simply run python 3 main.py. The result of it should be a bunch of HTML and a line at the bottom that states HTTP response code is 200. Now, if the program was run without the virtual environment active, it would throw a module not found error as request is not installed at the global level. Now that the program's working, the next step is to begin making the program transportable to another system. To start with, a list of all the packages that are installed in the virtual environment needs to be catalogued into a file that can be used to reinstall those packages. The reason for doing this is that we don't want to copy the virtual environment. Instead, you recreate it on the destination system. One reason is that adding a large number of packages can take a long time to push up to GitHub or any other source control system, and could also cause capacity limit warnings when pushing up to those systems. To get the list of installed packages and put them into a text file, run pip freeze greater than requirements.txt. Next, run ls-lha and a new file called requirements.txt is now present. To view the contents, run more requirements.txt. It will look similar to what's on the screen. The file contains the name and the exact version of each package that is needed to be installed in a virtual environment. This will allow for the project to be deployed to another system and use those exact same versions of the packages when you installed them. Typically, during a project's development, you may need to add additional packages after you've created the requirements.txt file. As a good practice, I'd recommend that the requirements.txt file is recreated when a new package is installed, so that there are no missing dependencies later on. For the final step, let's perform a mock deployment to another system by using a different folder on a computer. The steps to do this are basically what we've already gone through, with some minor tweaks. First, I'm going to open a new terminal tab. You can do a window if you want. Go to the location where you want to store the project files. I'm going to use the downloads folder again. Create a new folder in that downloads folder. In this case, I'm just going to use example 2. Then I'm going to go into that folder. Next, I'm going to copy the main.py and requirements.txt files into that folder. Then I'm going to create a new virtual environment, the same way as I did the previous one. And lastly, I'm going to activate the new virtual environment the same way as I've done before. Now, onto installing the dependencies. It's basically the same as we did before, but instead of using pip install and then whatever package names we want, what we're going to use is the requirements.txt file instead. To install the packages with the requirements.txt file, we need to run pip install -r requirements.txt. The -r switch implies that pip needs to read the contents of the requirements.txt file to get a list of the packages and their associated versions to install. If I then run pip list again, you see that the package is installed as they were previously. You can then run python3 main.py again, with the results being the same, although there might be a chance that it might be different depending upon the site that you used. If you were deploying to another system, the only thing that you would do differently is to first connect to the system, typically via SSH on Linux. Make sure that you have the correct version of Python installed on that system that was used to develop the project on. And that concludes how to set up and use a virtual environment with Python. Thanks for watching. If you liked the video, please like and subscribe, and I'll see you in the next video.